Okay, for this is section 4.3, problem number 37 first. I will try to get both on the video, and if not, I may just have to help outside of class with one because it takes me an hour to make each video, even though it's only about 10 minutes long. So I'll fit what I can on it. Now, this is a horrible drawing, but this is the H that you see, and they label some sides, but they don't label all of them. So I'm going to start off with labeling the sides that are here. Okay, now they didn't label everything, and we're going to go ahead and label them because we're going to need to know what it is. If this side's 4A, the other side's equal to it, so we're going to call it 4A. If this side is A, this side's equal to that side, even though I didn't draw it well. That's also equal to A. Likewise down here, I didn't draw it well, but if this side's A, this side's equal to it if you look at the drawing in the book, and it's A. So let's fill in all the pieces of it. Then they want us to find the perimeter. Well, the perimeter is simply adding all the sides together. So I'm going to start right here. I'm going to mark it so I don't accidentally count something two times. If I have an A and I add another A, that's a 2A. That's another A, that's 3A, 4A, 5A, 5A and 4A. See where the dots are? That makes 9A. Here's 10A, 11A, 12A, 13A, 14A, 14A, and 4A make 18A. So that's our perimeter. We just added all the sides up. It's just combining like terms. It's just a different way to kind of give you a combining like terms problem. For the area, here's what we could do. Let's draw different, let's separate our figure up. We don't have a formula for the figure of an H. So what we do is we look at sections. So what I'm going to do is I'm going to create two triangles here, and then there's in the middle, it ends up being another rectangle. Now if you look at your book especially, you notice that the rectangle on the left and the rectangle on the right are equal. So if I could find 2 times the area, let's just look at the one of rectangle on the left, because there's the one on the right's equal to it, and then I add in the area of the rectangle in the middle, I will have the area of this figure. So when we do this, it's called composite area. It means we take a figure, we split it up into lots of little sections, and then we figure out, what each section is, and then we add all the sections together. Now there's a rectangle. I know the area of a rectangle is length times width. Okay? Well, my length here, or my width, whichever one, it's one of the dimensions, it's 4A. And then this other direction, it has, like we'll say, width of A. So that's 4A squared. So now I know if I'm going to total that area up, I've got 2 of those 4A squareds, because the left rectangle and the right rectangle are congruent. Now let's look at the middle rectangle. The middle rectangle has one dimension is A. We can see that if I'm looking at this purple rectangle here. So if I'm looking at that one, it's also length times width, and one dimension is A. What is this dimension here, though? Okay, so we got to think for a minute. The whole thing, the whole length of one of the bigger sides on the H is 4A. But if you take out this A from it, we're down to 3A. And if you take out this A from it, we're down to 2A. That means this piece right here is really just 2A long. So if I need length times width, it would be A times 2A, which would be 2A squared. Okay, so if I want to add up all my area, it's 2 of these 4A squareds, and then a 2A squared. And again, 2 times 4A squared would be 8A squared plus 2A squared. And if I add it together, my total area would be 10A squared. So you're just breaking things into pieces and finding the dimensions of them and multiplying. 38, we have a 3-dimensional figure, and they want to know the total surface area. I actually took a picture of this and put it, well, you couldn't see it because it's probably out on core sites, but anyway, I'll just do it here again, and it'll be easier to get to it this way. Now, okay, I didn't do a good job here. Imagine that corner does not exist there. Let me just kind of black it out, okay? If we label the dimensions of this thing, this was A, this one was 2A, and this is 3A. Now there's a fancy surface area formula for a box, or it's called a rectangular prism. But, most of the time you don't remember it, and they didn't put it in the book because you really don't need it. Let's think about it this way. Let's look at this side right here. If this were a box, aren't there 2 sides that look like this? Think about a box. We could look at this as the front side and the back side. So I've got two of those rectangles, and it has a length of 3A, and then its height is the same as this A back here, isn't it? If that's A, then this is also A right here. So I have two rectangles with that area, and the surface area just means what's that flat surface area. So it would be 2 times the area of that. Well, isn't the area of 3A times A 3A squared? So if I'm going to keep a running total of all my surfaces or sides and their areas, 2 times 3A squared would mean I've got 6A squared just from those two pieces. Now I have some other, let's look at the two sides that would be like this. I have two of those rectangles. If I cut the box apart, you could tell that. Now I have 2A for this bottom piece of it here, so I'm going to label that. And then it's also A tall, isn't it? So if I look for the area of this little rectangle here, it's 2A times A. That would be 2A squared. Okay? But I have two sides that are 2A squared, so wouldn't that total up to 4A squared when I do those, look at both of those sides and just add those together? Now I have the top of the box and the bottom of the box, and if you look at it, this side right here is the same as this 3A down here, so it's 3A. And the side right here that I'm darkening as I speak, it's the same as this 2A down here, isn't it? So if I look at just that rectangle, it's 3A times 2A, and length times width just means we multiply those two numbers, so it will be 3A times 2A is 6A squared. But there were two of those, weren't there? So 2 times this 6A squared would give me 12A squared. Okay, there were 6 sides to the box, and I've looked at the area of all 6 sides, and I've written them out here in black, they were, as I doubled them. So now let's just total it up and see what the total surface area is. 6 of those A squareds plus 4 of those A squareds is 10 of those A squareds, and 10 of those A squareds plus 12 of those A squareds is 22 of those A squareds. There's your area.